Alright, so imagine a Cartesian plane. We've got our positive x direction, and we've got our negative x direction, positive y direction, and negative y direction. Now, imagine the point x equals 1, and the point x equals negative 1, and y equals 1, and y equals negative 1. If I were to write this as a coordinate point, this would be 1, 0. This would be 0, 1. This would be negative 1, 0. And this would be 0, negative 1. Now imagine I draw a circle to connect these points. Now this is what we call a unit circle. The distance from the center of the circle at 0, 0 to any point will be 1. So it's 1 unit, and hence it's called the unit circle. Now you can see that any line that we draw is going to have a height or a y component, and it's going to have an x component or the horizontal side. And so this point on the line and this point on the circle will have the coordinate x and y. Now we can describe where this line is on the circle by using theta, which is the angle between the positive x-axis and our line. So now say for example I draw this triangle over here. So this is theta, and we know that this here is 90 degrees. It's a right angle triangle, and we know the hypotenuse is 1, and this is y and this is x. Now using our trig knowledge, we know that sine theta will be y over 1. So y is just given by sine theta, and cos theta will just be x over 1. So in other words, x is just cos theta. So this y value here we can find by just doing sine of the angle between the x-axis and our line. And the x value can be given by doing cos theta. Another thing to note is this angle here is 90 degrees. So this line is 90 degrees. And this angle is 180 degrees. And if you keep going, this angle down here from our horizontal x-axis will be 270 degrees because it's made up of 3 90 degrees. And if you went all the way around and came back to the beginning, then that angle is 360 degrees. Now you'll also notice that anything in this quadrant is a reflection of anything in this quadrant. Now, so what do I mean by that? So if I draw this line here, if I draw the mirror image of that line, then I know that this angle here would be theta. This would be y, and this would be the same distance as this x, because this side of the quadrant is a reflection of this side. So if we were to write down what this point is, we would say x, y, but as you can see from the center, we are going towards the negative x direction. So it will actually be negative x and y. So there's a relationship between the second quadrant and the first quadrant if we know our theta values. Your y is going to be still sine of, so if this is theta, what is this angle here, which we would use to define this line? Well, the angle between the x-axis, the positive x-axis and the line will be 180 minus theta, because this line here is at an angle of 180 degrees and this angle here is theta, so this angle will be just 180 degrees minus theta. So here we can write 180 minus theta. And this here is going to be cos of 180. So we know that sine theta is the same as sine 180 minus theta. So we can say sine 180 minus theta is the same as sine of theta. And what we know for the cos is that cos theta is the same as negative of cos 180 minus theta. Because cos of 180 minus theta gives us negative x, but cos of theta gives us x. Now let's look at an example. Say, for example, our theta is 30 degrees. What does that mean? So if this was 30, we're saying that this y length is going to be sine 30. Now, if I drew another line here and this was 30, that means that angle will be 180 minus 30, which is 150, is the same as sine 150. And we can also say that cos of 30 is the same as negative cos of 150. Because cos 150 will give us a negative answer, and the negative of the negative will give us the positive x value. Let's also look at the third quadrant. Let's say I draw a line here, and this here is theta. Then what do I know about this? Well, I know that this again will be y in magnitude, but negative, because now we're going in the negative y direction. And this x will be the same as this x, because it's still part of that angle there. So for this point, we know that it will be negative x, negative y. And let's define this angle from our positive x-axis. Well, it's going to be 180 plus theta. So this will be given by sine 180 plus theta, and this value will be given by cos 180 plus theta. So what does that tell us about the third quadrant? Well, in the first quadrant, we knew that cos theta equals positive x, and cos 180 plus theta equals negative x. So cos theta is actually the negative of cos 180 plus theta. Now let's look at sine. So we've got positive y here, so sine theta is positive y, but here we can see that sine 180 plus theta actually has a negative y. So we're going to say this is negative of sine 180 plus theta. So this is what we would use in the third quadrant. This is what we would use in the second quadrant. This is how we would connect it to the first quadrant. And for the first quadrant, we don't really connect it to anything else. We just have sine theta and cos theta for x and y. Now, let's look at the fourth quadrant. Now, if I again draw this line here, and I say that this is theta. So again, if I split that into the y and the x, we know that this y is just going to be the negative of that. So we know that this point is going to have a negative y, but the x is in the positive direction. So we're going to have a positive x and a negative y. And how does this relate to the first quadrant? Cos theta equals x, and here also we have x. So we can say cos theta equals cos of, now what is this angle? If we are going all the way around till here, well, that's 360 minus theta. So we can say that. Another thing to note is our sine theta. So sine theta is the same as, so here sine theta gives us positive y, but sine 360 minus theta gives us negative y. So it's going to be negative minus theta. So that's the relationship of the first quadrant to the fourth quadrant. Now you may be thinking, why are we doing this connection of the second, third, and fourth quadrant to the first quadrant? Well, it's because we memorize a lot of the exact values for different thetas in the first quadrant. So, for example, we have this table. So we go across, we go 0, 30, 45, 60, and 90. And we write sine, cos, and tan. And that's the thetas. So these angles 0, 30, 45, 60, and 90 all come in the first quadrant between here and here. And this table is a way to help us remember them. And so once we know what the angle is in the first quadrant, we can always map them to the second, third, and fourth quadrant using these relationships. So, right, so let's do this. So to fill in this table, we begin with 0, 1, 2, 3, 4. Then we write that backwards. So we go 4, 3, 2, 1, 0. Square root everything. And then we divide by 2. And tan is the same as sine over cos. So we just look at the numerator and write that as a fraction. So 0 divided by 4 is just 0. Root 1 divided by root 3 is just 1 over root 3. Root 2 divided by square root of 2 is just 1. Root 3 divided by root 1 is just square root of 3. And square root of 4, which is 2, divided by 0. You can't divide by 0, so this is just undefined. So now we have all the values for sine and cosine and tan in the first quadrant. So we have 5 angles. Now, these correspond to angles on the line. So we've got this here, which is 0. Then we've got another one here, which is 30. Then we have another one, which is 45. Then we have 60, and then we have 90. So we are given, so this table gives us the x and the y, the y and the x component of those lines. So remember, sine theta gives us the y component. So it gives us this y value for each line. Cos theta gives us the x value for the line. Now say we want to find what is sine 30, or what is the y component of a line on the unit circle at 30 degrees from the positive x-axis. So to do that, we just look at our table. Sine 30 is square root of 1 over 2, which is the same as half. Great. Now say for example we want to find what is sine 150. Now 150 degrees isn't on our table, but we know that sine 150 is, so 150 degrees is this. So if this is 150, this here is 30 degrees. So we can write this as sine 180 minus 30. And we know from our second quadrant that sine 180 minus an angle is the same as sine of that angle. So sine of 180 minus 30 is the same as sine of 30. And we know that sine of 30 is a half. So this is just half. Say we have a line here, and that's 30, but all of this is 150. Then the y component of that will be the same as y component of sine 30, which is a half. So that's how this table and these connections between the quadrants helps us find the x and y components of different lines around the unit circle. Let's do another one. Say I want to find what's the x component of the line at angle 222. So what's the x component of that? So say I've got a line here. Well, I know the x component is the same as cos of theta, and it's in this quadrant because 225 is greater than 180 degrees but less than 270. And here we know that cos theta is the same as negative cos of 180 plus theta. So I can say that cos of 225 is the same as cos of 180 plus 45. So how does this relate to cos theta? Well, negative cos will equal cos 45. Now from this table, I know that cos 45 is root 2 on 2, which is the same as 1 over square root 2. But this is the negative of that. So root 2, so cos of 225 will be negative 1 over root 2. So we've found the x component of the line at 225 degrees will be negative 1 over root 2. So that's how the unit circle and this table here is helpful. It can help us find the x and y components of different radii around the circle at different degrees around the circle.